Okay, so a little bit more on getting the Triton to work. Since I filmed the video, we've obviously got quite a bit more functionality going now. So we've added and tuned the cassette system that involves setting the potentiometer so that we can get an exact frequency using the scope to get a frequency count on the UART oscillator. We've also built a cassette lead, so we've now got a cassette cable hooked up into a tape deck, and also some of the other ones that come off of the deck is we're waiting for the parts to build the sounder, which is built into Triton 7.1, 7.2 Humbug and Basic, so it makes beeping sounds and so you can have sound out. So what I've done in the meantime is two of the wires provide on this level a sort of built-in bit banged serial port. Unfortunately that's standard TTL positive going pulses, so this small device here is a USB TTL with a 7400, just using one of the gates to create an inverter so that the output is inverted, so it's normally high and then goes active low. The serial port is software emulated, so it's one start bit, 8 data bits, a false parity, which is mark basically, so it always goes low no matter what the parity is, and then 2 stop bits. So on the screen we've got a Minicom terminal running at 4800 baud. The built-in monitor sets up a delay that is equivalent to 110 bits per second, designed for a teletype. So you have to change one of the memory addresses. So if you use function P, it is 1402 that is set, and we've set that, it's set to F1 on a reset, so we're going to set that to 03, and we're going to set 1403 as 02, we're going to set that to 00, and then Control D to exit it, and now we should have a serial port working, and then we use option V, and now you'll see on the computer screen, you probably can't quite see it on camera, but if I reduce it, you will see that the output from the Triton is coming out on the screen. I'll move the keyboard debugger out of the way so that it's in shot. There we go. We'll put the keyboard debugger over here so we can see the key presses as we press them. Okay, so now basically every function we get will be both displayed on the TV and on the serial output, because everything's echoed after you press V. And that includes if you go into BASIC as well. So if we do a J to go into BASIC, and then the end address, we got the bytes free, we can do 10 4K equals 02255 step -1, 20 out 3 comma K, 30 next K, and we run that, we should see our little lights counting up. Hopefully, have we done it? Yep. Did he do it so fast we didn't see it? Yeah. Why is that not working? Oh, it's out K, yeah, out 3K. That's kind of, yeah. Oh, step -1 is always there. So it's 10 4K equals 1, 2, no, equals 255 to 1 step -1. We hold this that, and now we do a run, so we get for typing in too quick. And yeah, the LEDs are flickering up to count all the way up to 254 in this respect. Or down to 1, we don't ever get a full 0. Okay, so that's working. What I wanted to show you though is if we go back out of the BASIC into the monitor, and we do a hex dump of 1602, which is because 1600 and 1601 are the tape header addresses. So first few bytes, there's a bit of junk in there, but what we're going to do now, hopefully, is if we use the I to load from tape header, and we've got a program called memtest on there, which we press return, and then we press play on the tape deck, Hopefully in a moment you'll hear the sound of a Triton carrier tone. There we go. Okay, it's found mem test and now it's loaded it. Okay, the volume control is irrelevant because we're using the auxiliary in and out, which is a fixed level on the 5-pin connector on the back of the tape deck. Okay, so now we will be able to use the go function on the monitor, which will allow us to start at 1602. And that should flash the lights doing the memory test, which it does, and then it does the register dump, and we see that the final address it found was 4000 hex when it tried to write in FF and didn't get it back. I didn't get the 0 back after it left it at FF, which is the end of memory as we know it, because we've got the 8K memory expansion on the board. So that's working fine. But one of the little tricks where you might like to see is if we go to the key ASCII, we've also got a little program called here send T72, which is and then we've got a hex file called memtest.hex, and if I send that, what should happen is let's reset the machine so we've got a completely clean machine. Although actually that's going to happen when I do the mem test. So now we won't be seeing it echoed on the screen because we've lost the settings for the echo, but that doesn't matter, it's still on the TV in the background. The principle being that we do a send T72 mem test, and that uses the monitor now to take control of the keyboard and starts programming in the data onto the Triton by typing in the hex because it's simulating the keyboard. So it loads in the hex, and when it's finished loading in the hex for the program, this is how I got it in originally, then it now uses the G function in order to run the code automatically, and it does the memory test and then comes back. So now we can develop code on the PC, send it to the Triton, and off it goes. So I've got one as well for typing in BASIC, but it's not fully functional yet. Of course, both of these things are based on the Python scripts developed by Sirius Hardware on the VintageRadio.net for the MK14 programmer, the Pi, which is what we're using. Underneath you can see it with the adapter board. So there we go, making progress with the Triton. We can now send it at assembly language at a reasonable pace, reliably, and we can save it to tape as well. And we can get output from it, so if we've typed a basic listing in, we can just print that out to the screen and be able to capture it. So anything we type in BASIC, or even a hex dump as well, we can recover into the PC. So we're not completely trapped with, we've got 2 different ways of saving and loading data for the Triton. Moving forward, we'll hopefully be able to put basic programs straight in. We just got to get the timing right so it types it in.